and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? So let me just turn on my preview screen. So let me just see if I'm visible as well as equally audible or not. Okay. Just quickly send me a 1 in the chat. Okay, just let me check. Okay, I should be. Stream health is good enough. Okay, so let's start a timer for the next 1 minute and then we would start right away. Okay, so the stream would start, we would start discussing the problems after the consumption of 1 minute. Okay, sorry. Okay, fair enough. Thanks a lot, Coders Live. Thanks a lot, Ganesha. Thanks a lot, Dave Bird. Okay, let me now load on the proletariat. So, how was the contest for you today? We have only 15 seconds left. So, Dave, Ganesh, and Coders. So, how was the contest? How many problems were you able to solve? Okay, now let's start with the very first problem, which was given two numbers. Okay, given two numbers A and B. So in this problem, we are given two numbers A and B. Okay, so we have A and B, and in one operation, you can pick up any non-negative. That means you can pick up the positive numbers and 0. Okay, and the negative ones we can't take. So 0 and positive. Just remember this. Okay, integer x and either of A or B. Okay, and either of A and B. Then what you can do is you can replace A with A and x और B with B and x. So basically करना क्या है कि दो नंबर दिए गए हैं A और B. ओके, अब कोई भी एक नंबर उठाओ जो पॉजिटिव या 0 हो और आइदर A को एंड करके वो नंबर कर दो, like A is equals to A and x or B is equals to B and x. You can do these things. Okay, you can do only these two things itself. Okay, fair enough. Now and represents, okay, so and represent the bitwise AND operation. So let us first quickly have a revision of the truth table of AND. So suppose we have 0. Okay, suppose we have 0 and we do a AND with 1. Okay, then the AND of both would be 0. Then we have 1 and 1, then the value would be 1. If we have 0 and 0, then the value would be 0. Okay, then we have 1 and 0, then the value would be 0 itself. Okay, fair enough. This is the truth table of AND. Now let us go back. Suppose we have A and B. So we have A as 5 itself. Okay, so we have A has 5 itself. So the value is like this. Okay, 4 plus 1. This is 2 to the power 0, 2 to the power 1, 2 to the power 2. That is nothing but 2 to the power 2 plus 2 to the power 0. And then we have the next number as 12. So we have 1, 1, 0, 0. That is 2 to the power 3 plus 2 to the power 2. That is 8 plus 4. That is 12. So now we have the number as this itself. Fair enough? Now, in the first operation, we would replace A with A and 4. Okay? But don't go with this explanation. Just try to make A and B equal. So if you want to make A and B equal, then how many bits we have? Suppose we have 1, 0, 1. Then let's add 0 here. We can add 0 here. Then we have 1, 1 and we have 0, 0. Fair enough? Then suppose we want to make this as 0. Suppose we want to turn off this bit. ये वाली bit को 0 करना. Because suppose we have 1, then by no means, suppose we have 0, and even if we do a AND with 1 or 0 AND with 0, then the value would be 0 only. मतलब जो bit बंद है उसको 1 तो नहीं कर सकते, 0 को 1 नहीं कर सकते, 1 को 0 कर सकते. So what I'm trying to say is, if the value is 0, then we can't change it to 1 by no means, because if we do a AND with 1 also, if we do a AND with 0 also, we can't do it. But if we do 1 and 1, then it would remain as 1. 1 and 0, then it will be changed to 0. So if the bit is turned on, we can keep it turned on or we can turn it off. We can do either of the ways itself. Okay, we can do either of the ways. Okay, first thing is understood now. Now suppose the next thing, suppose I want to make this bit turned off. That means I need to do this AND with 0. Next I come to this bit, both bits are same, so we don't need to do anything. We don't need to do anything. Here, I can't turn on a bit, but I can turn off a bit. So what I would do instead is, I would have this bit turned off. So first, we have the values at 1, 0, 1, and we have the next value as 1, 1, 0, 0. So what we can do is, we need to turn off this bit and we need to turn off this bit. So this means that to turn off this bit, what I can do is, I can do a AND with 0, 0, 1, 0. So that other bits are preserved, but this bit would be turned off. So now if we do the AND operation of it, then it would become off, off, on, off. And if you want to turn off this bit, then you need to do a AND with 0. And if you want to preserve those bits, then you do need to do the AND with the same thing. Like 1 should be done AND with 1 only, 0 should be done with 0 only, and then 0, 0, 1, and then 1, 0 would make it 0 only. Like we have 100, and the next one is also 100 itself. So how many operations we did? We did AND here also, and here also. So we did 2 operations. That's why the output to this is 2. Okay? So can I have a quick +1? So मतलब क्या कर रहे हैं ना, हमें पता है कि अगर बिट 0 है तो उसको टर्न ऑन तो नहीं कर सकते. ओके, मगर जो चालू है उसको बंद तो जरूर कर सकते हैं. तो जितने चालू बिट डिफरेंसेस में है उसको बंद करने की कोशिश करते हैं. अब जो बिट चेंज नहीं करना है उसको सेम कॉपी कर दो. Simple enough. Can I have a quick +1 if this is understood? Because this is the crux of the solution. Quickly let me know. Ganesh, Devbhat, Coders, Chirag, quickly let me know. Okay, Chirag is done. Ganesh, Devbhat, quickly let me know. And Coders live. Now I would wait for the next 1 minute so that everyone just replies. Okay, so how many students are done? So I think this problem is done as of now. As of now, this explanation is clear. Now let us move forward. Okay, let me just check. Yeah. So now let us just move forward to this. So now if we move forward, okay, so just let me check. Okay, so now if we move forward, we can see that we need to turn off this bit. But there is one more solution to it. Like if we have 0, 1, 0, 1, and if we have 1, 1, 0, 0, and if we do a AND with 0, then everything would become 0. And if we do a AND with 0, then everything would become 0. So howsoever the differences is, we can make this, we can make all that both the numbers as 0 itself, because doing AND with 0 is allowed to us. Okay, doing AND with 0 is allowed to us. We can do that. So in the worst scenario, the maximum answer would be 2. Okay, in the worst scenario, the maximum answer can be 2. So up till now, we have learned that up till now, if the numbers is same, if both are same, then we require 0 operation. If both is absolutely different, that is in the worst scenario, we would need 2 operation. Okay, so when is the condition where we require 1 operation? Because in the worst scenario 2 is the operation, so more than 2 we won't ever encounter. Less than 2 can't happen, because if the number is same. So we just need to say that when would be the case when we would require only one number. So one number is needed when we need to turn off a bit in just one number. Like I would say you, suppose we have the first number as 1, the next number as 0. Suppose we have the first number as 1 and the next number as 0. So if we want to make it equal, then we can just do a AND with 0. This would become 0. This is already 0. Let me give you one more example to it. Suppose we have 1, 0, 1, 1, and then we have 1, 0, 1, 0, like these two numbers. Suppose we have these two numbers. Then if we do a AND with 0, okay, 0 and this is 1, okay, this is 1, this is 0, and this is again 1, and this would make it 0, this would keep it 1, this would make it 0, this would make it 1. And if we do a AND, if we don't do AND to this number also, then this number is equal to this number. See, this number is equal to this number. This is the reason to it. Fair enough? So we can say that the minimum of them, if it is minimum of them is equal to some number, then we need one operation. So in case of minimum, we need one operation. If it is same, we need 0 operation. In the worst scenario, we need 2 operation. Okay, so we can just check if it is same, we would return 0. If minimum, then we would return 1. Else in all other condition, we would return the worst scenario as 2 itself. Now we would just start the implementation itself. Okay, now let us move to the implementation. I would just change the color. Okay, change color is changed. Now I would go here and let me just start. So we are given A and B. So first we would check as told, if A is equals to, if A is equals to B, that means if A is equals to B, we would return the value 0. We don't require it. Then if A and B, that is A and B is equal to the minimum of A and B, if they differ by only one bit, or we just need to turn off a bit at a particular, only one value, not both the values. Okay, if this is the condition, we would return 1, else we would return 2 itself. Now let us just compile and run and see if we can get an AC or not. First we would compile and run sample test case. Yes, a correct outcome is a sample test case. Now let us just submit. And yes, this thing is clear. Now I would wait for the next 1 minute If you have any doubts, just mention the line number and I would explain it to you. So I would just be here. Yeah, this is fine. Just mention the line number itself. Just mention the line number if you are clear to this problem. Then we would move forward to the next problem. Ganesh, Ankit, Chirag, Dev, and Coder's Life. Quickly tell me if these things are clear to you or not. Line number 13, can you please explain it once? Okay, like we need to just change one bit. Like I would just explain you. See, if you go and observe this, see, let us take the scenario where we need to change. Okay, let's take one more scenario. Suppose we have 1 0 1 1 0, and the next number is 1 0 0 0, and then again 0. So what we need to do is we need to turn off this trigger. So if we do the AND of those, then this value would be 0, 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 this value would be 1, which is nothing to but the minimum of that. See, minimum of that would be this. That is why we are saying that if we are doing a and B, and if it is equal to minimum of A and B, then we are returning 1. That means we need to change only one number. Am I clear, Ganesh? Sure. I'm waiting for you. Just quickly confirm that I'm clear or not. Can you please confirm, Ganesh? Sure. We are waiting for you. Okay, I think that Ganesh is not here. Okay, thanks a lot. Okay, I would stop this, reset this, and then I would go back and I would go to the tree formation. Okay, this problem seems to be a little difficult, but this problem is easy. How? I would tell you. Here we are told that we are given a connected. What do you mean by connected? That means only one connected component is there. Everyone is connected, no more than one connected component is not there. Then it is told that it is undirected. So we don't have directions at all. With n nodes, in one move, you can merge any two adjacent nodes. Like suppose A is there and then we have B. So A's adjacent node is B but not C, because this is directly connected. Or you can say that you can merge two directly connected nodes, not adjacent. I'm here, actually it's a delay. Yeah, it's a delay of around 20 to 30 seconds. It's a delay. We need to cope up with that. So calculate the minimum number of moves required to turn this tree into a start tree. So what do you mean by start tree? Here the definition is given, but I would help you to analyze it. A start tree is a tree where there would be a central node and all the other nodes would be connected to the central nodes itself. This is a star tree. There cannot be something like this. We need everyone to be like this, like a starfish form. Okay? Fair enough. Then let us first try to solve the sample test case. मतलब एक ट्री दिया रहेगा जिसमें एक ही कनेक्टेड कंपोनेंट होंगे, मतलब सब एकजुट रहेंगे, एंड नोड्स दिया रहेगा और एक मूव में दो एडजेसेंट नोड्स रहेंगे बगल बगल, ओके, जो डायरेक्टली कनेक्टेड है, उसको आप एक बना सकते हैं. ठीक है, अब मिनिमम नंबर बताना है जिससे सबको एक स्टार ट्री में कन्वर्ट कर सके. ओके, सो लेट्स फर्स्ट ट्राई टू सॉल्व दिस. Okay, so let us now mark the indices. The indices are 0, 1, 2, 3, and 4. So for 0, there is no parent. Okay, for 0, there is no parent. Now for 1, the parent is 0. 1, the parent is 0. For 2, the parent is 0. For 3, the parent is 1. For 4, the parent is 1. This is how we are building up the tree. So if you just look up 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, this is how we are doing it. Okay, these are mentioned. So now the tree is clear. Now we would just try to make it a star form. Okay, so these two are already in the star form. So what we need to do is we need to take up this, and if you keep this, okay, and if you connect it here, that means how much? One operation is done. Then again this thing is there. So what you can do is you can take up this thing and then you can keep it here. As it is upside, so I would just make it downside and I can keep it here. So 1 plus 1 would make it 2 itself. Okay, so now as we did, we can just solve it in the same way. Okay, in the same way as we processed in the given one. Okay, I would just write it here. Solve it same way. Just solve it the same way as we did. Just tell me if things are clear to you or not. How we are getting the output as 2 for the given one. Okay. As of now, this is not the optimal. The output is 1. Okay. The output is 1 as of now. The output is 1 as of now. But the unoptimal one, is this clear or not? Okay, so no doubts as of now. So now the next scenario. Okay, so now in this scenario, as we have already built up the tree, so I won't build up the tree again. I would just take a screenshot of that. So now in this scenario, we can see that if we just merge these 0 and 2, 1, 3 and 4, and then we have 0 and 2 merged as 2, then we can say that yes, this is also a star form. So कंक्लूजन ये आता है कि हमेशा स्टार का सेंट्रल 0 नहीं रहेगा. It can be 1, it can be 2, it can be 0, it can be 4, anything. The star in the central part, it can be any node. This is what I want to say. So now, how can I solve this problem? So is this thing clear or not? Can you please like the video? The number of live viewers is 15, but the number of like count is just 9. So just like the video quickly if possible. Okay, fair enough. The central node can be anything. If the central node can be anything, then what we need to do is we just need to count the number of operation. Okay, what I'm trying to say is, see here, see, the problems we have is with these all nodes, but we don't have a problem with so-called leaf nodes. We don't have a problem with them. We don't have a problem. So the number of leaf node is 3. Total number of nodes is 5. So if we subtract 5 minus the number of problems minus 1, okay, number of problems whole minus 1, then 5 minus 3 is equals to 2. 2 minus 1 is equals to 1. And yes, we have this value. So I'm just telling you again. देखो ये 3, 4, 2 ये सब लीफ नोड है, तो इसमें ज्यादा झमेला है नहीं. जो झमेला है बीच में है. So क्या कर सकते हैं? We can remove the problems. ये सारी झमेला हटा दो. We can remove those problems, and number of nodes remaining would be the number of nodes that needs to be fixed. This is what we would do. Total number of nodes minus the number of nodes which does not need to be modified minus 1, and then we would be returning them. Am I clear to this or not? So now, how we can solve it? To solve this problem, we would just find the number of, so we are given the parent array. So what we can do is, suppose the parent has a connection. So see, it is telling me that for 1, the parent is 0. So it means that I have an edge from 1 to 0. I have an edge from 1 to 0. That means this also has an incoming edge, this also has an incoming as well as outgoing edge. So all the nodes which have only one incoming and outgoing edge, that is only one edge towards it, would be the one that won't cause problem. Matlab, suppose we are given the arrays. Okay, suppose we are given that for 1 the parent is 0. Okay, this means that we have an edge from 0 to 1. So what we would do is, for I as well as for the parent, both we would hash the values. And suppose we have just this value. That means for this, suppose we have like this. This in this part, 0 would be having the value 2, but 1 would be having the value 1. Okay, and 2 would be having the value 1. So we can say that all the nodes which have the number of edges from it as 1, these would be the nodes that won't cause a problem. I can say that. Yes, I can. So what I would do is, I would move forward and just count the number of edges. How would I count this? To count this, I would just use the parent array. So let me just show you. Let me take the screenshot of the parent array. Okay. And let us take this array also as this tree also as a reference, that we are getting a correct output or not. See, we are told that for 0, 1, 2, 3 and 4. Okay, we can do this. So now let us do for this one. So we are told that for 1 the parent is 0. So we have 0, 1, 2, 3, 4. So for 0 the parent is 1. So we would go to 0, we would add 1 to it. We would go to 1, we would add 1 to it. Then we would go to 2, we would add 1 to it. Then we would go to 0, we would add 1 to it. 1 plus 1, that is 2. Then we would go to 3 and add 1 to it. Then we would go to 1 and add 1 to it. Then we would go to 4, add 1 to it. Then we would go to 1 and add 1 to it. So now you can see that all the nodes which have the number of edges as 1, these are the leaf nodes. 2, 3, 4. 2, 3, 4. For 0, we have 2 edges. Yes, 0 has 2 edges. 1, we have like this. 1, 2, 3. So this is a popular way of counting the number of edges. So we are just counting the number of edge from each node. This is just a popular way. Okay. Am I clear till this point or not? Just can I have a quick +1? I just want to know if things are clear to you or not. Okay. This is how we would count. So now I would just, before start implementing, I would still wait for the next 1 minute. And if you have any doubts, consider asking me how we are doing that. So now we would just count the number of edges. Okay. Then we would subtract the number of edges that does not need modification, and then subtract 1 out of it. This is what we would do. So 25 seconds still left. Quickly tell me if you have any issues or not. Or else I would start the explanation part. I would start the implementation part, sorry. The count of edges is nothing. Suppose we are told Suppose we are told that we have an edge. Suppose one's parent is 0. So I would just count. So I would just again do it. Okay. Suppose we are told that from 1, I have for 0, the parent is 1. So I would go to 1 and I would hash 1. I would say that yes, earlier it was 0. Let's just add 0. So 0, 0, 1, 2, 3, and 4. Everyone initially has the value as 0, 0, 0, 0, 0. So we are told that 0's parent is 1. That means we have an edge from 0 to 1. Yes. So we would go to 0 and increment 1. We would go to 1 and increment 1. Then we are told that we have an edge from 2 to 0. So we would go to 2 and we would add 1. We would go to 0 and we would add 1. Then we are told that we have an edge from 3 to 1. We would go to 3 and we would add 1. We would go to 1 and add 1. Then we have an edge from 4 to 1. We would go to 4, add 1. We would go to 1 and add 3. Okay. So now if you observe counting of edges, we are told that 0 has 2 edges. Yes, 0 has 2 edges, this and this. Then we are told 1 has 3 edges. 1, 2, 3. Fair enough. Then 2 has 1 edges. Yes, 2 has only 1 edge like this. 3 has 1 edge like this. Then 4 has 1 edge like this. So yes, this is how we are counting the number of edges. So quickly tell me, if Roshan Singh, quickly tell me if things are clear to you or not. Now let us start the implementation because only one doubt was received and I have concluded it. So now to hash the values from 0 till n minus 1, what we would do is we would have vector of int of let us say frequency array of n plus 1 comma 0. Okay, initially all the values would be 0 itself. I would make it smaller case. Then I would move forward. int i is equals to 1. I is less than equal to n. Okay, and I plus plus. Okay, I is less than equal to n and I plus plus. Now suppose we are standing at this position, then we would say 0, 1, 2 and 3. Okay, 0, 1, 2 and 3. Okay, so p, okay, this would be p dot size. Okay, so p dot size, and this is done itself. Next what we would do is we would hash the values of g of p of I, and we would do plus plus. Then we would hash the current index also, because we told if we have an edge from 1 to 0, that means we would hash the values of 1 as well as 0. So we would hash f of I and then plus plus. Okay, f of p of I, then I plus plus. Then we go down. Now we initialize the count with 0. Okay, now we would initialize for int I is equals to 0, I is less than n, and then I plus plus. Then if f of I is equals to 1, that means there is only one edge, that is at a leaf node, then we would count the values c in plus plus, cnt plus plus. Okay, then we would modify the count to count of number of so total number of nodes minus the number of nodes which does not require modification. बस हम जो 5 नोड है जिसमें 2 नोड को मॉडिफिकेशन नहीं चाहिए, so we would do that only. So cnt is equals to total number of nodes minus the number of count itself. Okay, we have this. Then we would return max of cnt minus 1 and 0, because it might be the case that count is equals to 0. Okay, count is equals to 0 and 0 minus 1 is equals to minus 1, but in the worst scenario we would require, in the best scenario we would require at least 0. We can't do on the negative side, the value would be positive. So let me start doing this. Yes, this is correct for sample test case. And yes, it is absolutely correct. Now let us move to the very. So now is this problem clear or not? Quickly tell me if this problem is clear or not. I would wait for the next 1 minute. Okay, so as there is no doubts as of now, so I would just stop this thing and then we would move forward. There was a delay of 20 seconds, so I considered waiting for more 20 seconds more. Okay, so now let us proceed. Okay, yeah, we can proceed. Just taking the stream health. Stream health drop framed is 0.1%, which is absolutely negligible, so we can move forward. Okay, now let us move forward to the next problem. The next problem is very much interesting. Very much interesting. Just a simple idea and boom, you would be done. Okay. So I won't read the problem statement because the problem statement is a little bit big. So what I would be doing is I would be explaining you the problem statement instead. So we are told that we are given a graph. Okay. We are told that we are given a graph. And the graph is a weighted graph. Weighted graph. And what is the weight? Let us just see the weight. And the weights of the graph is less than equal to 10 to the power 5. Okay, n and m, that means with positive weights. Okay, with positive weights. So it is positive weights. So we have a positive weighted graph. Okay, suppose we have like this, like this. Okay, then from each node we have a normal edge and a curved edge. Normal edge and a curved edge. There are two types of path for each one. Okay, normal and a curve. Normal and a curve. We can have that. Now we proceed forward. Okay, now we proceed forward. We are told that there would be a source and a destination. There would be provided like this. Here it is told that you are given two vertices A and B. That means source and a destination. So you would be provided with a source and a destination. A source and a destination. And you need to reach the source to the destination. Okay, by using only one curved edge. One curved edge. We can't use more than one curved edge. Where it is mentioned, your task is to state path. You are given to vertices series such that you have at most one curved edge. So this just means that either you can use zero curved edge or you can use one curved edge. But you can't use other than that. Okay. So as we have only two options, let us first consider the case for where we can't use the curved edge. So if we can't use the curved edge, then simple we can calculate the path, shortest path from A to B. How would we calculate the shortest path from A to B? If we are given a weighted graph with positive weights and we want to find the shortest path from a single source, so if we want to find single source, so single if there is a single source and it is a weighted graph with positive weights, then if we want to find the shortest path, then we need to use something known as Dijkstra. So Dijkstra is a prerequisite of this problem. Dijkstra is a prerequisite of this problem. Okay, so you need to learn Dijkstra. Okay, so if you are watching the recording, consider pausing the video, learning Dijkstra, and then again coming back. So as you are picking up a graph problem, so assume that you have already learned Dijkstra. Okay, and I don't want you to again go through the same things that you have went through and invested your time. So I want to do justice to them which already know Dijkstra, which already does not know, just read and come back. I have explained Dijkstra in my video. Just search Dijkstra Siddharth and I would get my video only. Okay, and Dijkstra is a prerequisite here. So if we were not allowed to use any zero node, what we can do is we can have used Dijkstra and we can consider from A to B. Okay, simple. Just let me know if the scenario for 0 is clear or not. 0 is done or not. Then we would see for 1. First tell me if the 0 is done or not. And if you want me to teach Dijkstra now only in brief, consider asking me in the chat only. I won't have any issues. If you're willing to wait, I don't have any issues. So we have 35 seconds still left. So quickly tell me if you what you want me to do. Is this scenario for the case 0 clear or not? From A to B. So I assume that this thing is clear because even with a lag of 20 seconds, you would still have 40 seconds to analyze. Okay. So now let's use the scenario where you would need to use one edge. Okay. So now suppose we have like this, and for each one we have an edge like this. Okay, suppose this is the source, this is the destination, and this is the shortest one. So now what I can do is I can first come here. Okay, I can first come here and I can say that use all the straight nodes and reach here, and then I can go to the next node and I can use this curved path, and then I can say that use all the straight nodes and come from here. मतलब क्या करना है ना, एक नोड पकड़ेंगे, हम बोलेंगे सोर्स तुम वहां तक स्ट्रेट नोड यूज करके पहुंच जाओ, दूसरे ही वाले नोड पकड़ेंगे, बोलेंगे डेस्टिनेशन तुम सारा स्ट्रेट यूज करके पहुंच जाओ. मतलब व्हाट वी आर ट्राइंग टू डू इज कि एक कर्व्ड एज यूज करेंगे और बाकी सारे के लिए शॉर्टेस्ट पाथ यूज करेंगे. मतलब यहां से यहां शॉर्टेस्ट पाथ, यहां से यहां शॉर्टेस्ट पाथ, बस एक कर्व्ड एज यूज किया मैंने. Okay, and then I would have the cost of it. Okay, now the next scenario. Okay, now the next scenario where I would be using one curved edge of it, and then I would be using the straight edge of these. I can do that. I can use, okay, now this is the destination. Now what I can do is I can use this curved edge and you can use this destination edge. Okay. In the same way, I can use this curved edge and I can use the streams or streams. So now सिर्फ एक ही कंसिडर करना है. So what we would do is we would consider each curved edge again and each curved edge once again. Okay, so this is how we would calculate the value for the minimum number. मतलब क्या करना है कि from here to here we would use the shortest path by Dijkstra. From here to here we would use the shortest path by Dijkstra और एक curved edge बीच से use कर लो. Am I clear to this or not? मैं फिर से बोलता हूँ. ओके, सपोज एक नोड यहाँ है, एक नोड यहाँ है, एक नोड यहाँ है, एक नोड यहाँ है. ओके, सपोज देयर इज अ ब्रोकन रोड हेयर, ब्रोकन रोड हेयर, ब्रोकन रोड हेयर. अब मेरे पापा ने मुझे कहा कि मैक्स टू मैक्स एक ब्रोकन रोड से जाना. सो मैं क्या करूंगा, सारे स्ट्रेट पाथ से जाऊंगा और एक ब्रोकन रोड यूज कर लूंगा, फिर देखूंगा ये जर्नी कैसा था. ठीक है. नेक्स्ट व्हाट आई कैन डू इज एक ब्रोकन रोड से गया, बाकी सारा स्ट्रेट पाथ यूज कर लिया, फिर देखूंगा जर्नी कैसा है. फिर एक ब्रोकन रोड यूज किया, बाकी सारा स्ट्रेट पाथ यूज कर लिया, फिर देखूंगा जर्नी कैसा है. और जिसमें जर्नी सबसे बेस्ट रहेगा वी वुड यूज दैट पाथ ओनली, दैट ब्रोकन रूट ओनली. Am I clear or not? Quickly tell me. So I would be waiting for the next 1 minute. Just tell me things are clear to you or not. Let me look at the stream health. 0.1%, absolutely fine. Just tell me the things are clear to you or not. पाथ यूज कर, फिर देखूंगा जर्नी कैसा. We have only 8 seconds left. 7, 6, 5, 4, 3, 2, and 1. Now we are stopping it. Okay, fair enough. So now what we would do is how to implement it. To implement it, we would run a Dijkstra. To implement it, what we would do is we would run a Dijkstra from A, and then we would again run a Dijkstra from B. We would run a Dijkstra from A as well as B. Okay, then I would move forward. Okay, then I would move forward, and so this Dijkstra A and Dijkstra B, then I would consider all curved path. I would consider all the curved path. As the implementation is very long, so I won't be writing it. Okay, so I would be showing you and explaining it. So now if I move back to the implementation, so what we are doing is we are having a priority queue, then we are having the distance as 0, then we are pushing the source here. So I would just explain the Dijkstra once. Dijkstra में कुछ करना नहीं है, बस BFS के जगह, BFS में Q के जगह बस priority queue use कर. तो सबसे पहले आया, we are popping up that, and next if the distance is greater, we are trying to improve it. If the distance is less, we don't do it. This is Dijkstra. Now this thing, first we are building up the graph here. Okay, U to V with the edge as W. So this is the part where we are building up the graph, and in another point we are building up the curved edges also. The curved अलग है, straight अलग है. This is building up the graph with straight edges, and this is just keeping the curved path. Then we are learning a Dijkstra from A. We are learning a Dijkstra from B. That is from A to B. Then we are doing from B to A. Next, we are initializing an answer of DA to B. Why? Because we would handle the case with 0. This is the case. This is the initializing with 0 curved path. 0 curved path. This is building graph. This is the point where we are building the graph. Building the graph itself. Okay. This is from A to B. This is Dijkstra from B to A. And this is Dijkstra. Okay. Fair enough. Then after Dijkstra of A to B and B to A is done, then we would be moving forward and we would be coming here. We would take up the curved path, and then first we would reach from DA to U, then a curved path, and then U to V. Or else DA to V, like I will just tell you, see, A hai, B hai, A curved path hai, and then we have C. Okay, suppose we have C. So क्या कर रहे हैं? First we are going from A to B. Okay, then we are using this curved path. This is the curved path. This is D of this, and this part, this clear part is this. Next we are doing just the opposite of it. This is the complete solution of it. So now tell me if things are clear to you or not. Just quickly tell me if things are clear to you or not. I would wait for the next 1 minute. So now I would wait for the next 1 minute and see if there is any doubts persisting or not. So what are the things we have learned? So we have learned about minimum operation, where we saw we just can turn off this, we can turn off a bit and we can't turn on a bit. That kind of led us to the solution. Then we did tree transformation, where when evaluating the test cases, we found that the leaf nodes are very loyal and they won't disturb. So we just removed the loyal ones, and the remaining ones would be the answer. Shortest path using at most one curved edge is that we can use 0 edge, first solve it for 0 edge, then solve it for 1 edge. तो पहला का इंट्यूशन यही था कि एक बिट को टर्न ऑफ कर सकते हैं बट ऑन नहीं. दूसरे का इंट्यूशन ये था कि जो चाइल्ड नोड्स है वो परेशानी नहीं कर रहे. थर्ड का इंट्यूशन यही था कि एटमोस्ट वन कर्व्ड एज है, दैट मीन्स आई कैन यूज 0 कर्व्ड एज और 1 कर्व्ड एज. 0 के लिए सॉल्व करो, फिर 1 के लिए सॉल्व करो, एंड यू वुड बी डन. Okay, fair enough. So I have received no doubts. 1 minute 20 seconds is there. So that's it for today. Humble request from my side, if you think that I have invested my hard work over here, consider leaving a comment on this video. It brings a smile on my face, as well as it increases the reach of this video. So that's it for today. Thank you and have a nice day.